Next on the agenda, we have a keynote from Mosquera, who will be talking on extending Jenkins with Spinnaker. Isaac is CTO and co-founder at Armory. With his keynote, please welcome Isaac Mosquera.
In 2005, I had my very first startup. Now, looking back, my co-founder and I did something that was really smart. In 2005, Facebook also wasn't as dominant as it was today, although social startups were all the rage. And so we decided to prepend social in front of recipes. And that was not the smartest move, as we came to find out. But there was something that we did that was pretty smart. Now, in 2005, you needed a place to host your service. Now, there weren't very many places. We decided to use virtual private servers, but you only had a few other options, like either managed services or like dedicated services or dedicated hosting facilities. Now, for those who don't know, a virtual private server was kind of like the predecessor to what we know as AWS, except there was a lot of manual clicking and interaction. So you would go onto this website, click a whole bunch of different buttons, and then you'd hit that last button and it would provision for you a VM. And then I would SSH into that VM, and because I was a lot younger in 2005, I had a lot more hair, but I was just very naive about automation. It wasn't a thing that I really cared about or even knew about. I would manually do everything. I would manually set up the Apache web server. Yes, the Apache web server was also the most dominant web server at the time. We would also configure Tomcat, and we would have ourselves an internet service that people could consume. And then in 2006, something new came out that was called EC2. Now, for us, at first, it seemed a bit risky to move to this new thing called EC2 that came from what was an internet bookstore at the time. But it also had S3, so we had image storage, which was important to our social startup, and SQS, and the queuing systems, which was also really important for us. And so we jumped over to AWS, and we made that bet, because at the time we didn't, it was still a new service. And looking back now, that was the greatest move, because what we didn't know was that there was going to be another 15 years of innovation in that AWS was going to be the cloud technology to really kind of lead the innovation. Now, the other thing that I think is more important than just kind of that innovation is the behavioral changes that happened to me. Because AWS was not about giving you something that was like, hey, here's a VM. AWS really ushered in this idea of automation. And so I saved an enormous amount of time by moving to EC2, not because of the VM was so much different. It was because everything that it was about automation and reducing the overhead of operational scripting and things that you had to do. That was an amazing change. Now, they didn't stop there. So in 2011, they came out with Beanstalk, which abstracted out a lot of things. And then in 2012, they let you host on, your entire website on S3, which means I no longer had to configure web servers or Apache servers, so that was great. I just had to figure out how the deployment process was going to happen in S3. And so let's see, that was 2012. Now in 2014 was another big change in compute, which they came out with ECS. They also came out with Lambda, and they were ignoring the freight train that was called Kubernetes at the time. So that's why they came out with ECS. They didn't want you to move workloads off of their service. Of course, they would want you to stay with Amazon. And so this was another great move in innovation. Now I don't even have to worry about servers. I can just purely focus on my code with respects to Lambda. Again, I just have to figure out how to get my code up there safely. And then in 2018, they came out with EKS. Right. Now, in between, there was a lot of other innovation. Things like RDS came out around here. There was around here, there was also, EMR. And a lot of other places to run compute, right? In different styles, right? Like EMR was all about Hadoop, right? And so this is the rough timeline, plus thousands of other services, but these are the ones that really kind of stick out in my head. And then from there, also, what was happening was this cool little thing called Google App Engine came out. And Google App Engine was this really cool way of running your code and application. And it was basically the beginnings of GCP. From Google App Engine, they also released VM support. They also released a thing called Kubernetes that you might be familiar with, and they call their hosted version Google Kubernetes Engine. They also had functions. They also had a serverless platform called Cloud Run, which is fantastic. And Azure was doing the same thing. So they also had this thing called the App Service. They also had VMs, obviously a very popular operating system you might know as Windows. They have AKS, they have functions, they have serverless. Now, being able to kind of manage and control the way developers deploy to all of these services, kind of impossible. We've set ourselves up for an impossible task because the clouds are pouring in billions of dollars in R&D. And I couldn't fit all the services that Azure, GCP, and AWS have on one slide. But the reality is that your development teams need to use many of these technologies and sometimes across clouds. Now, you may say, Isaac, I'm not a multi-cloud operation. And there's probably a lot of companies that are not multi-cloud. But you are absolutely multi-target. You deploy to many of these different locations, even within a single cloud. You don't deploy to AWS. What used to be just EC2, you could just deploy to EC2, and that meant you were deploying to AWS, is now a multitude of services. So let's define what a target is. A target is a final destination where configuration or code will be applied after the delivery process is complete. And if you think about that as a target, then databases become targets, right? That's where configuration, database schema will be a target. Now, why it's important to define even the word target is because anything that is a target then needs to be audited, needs to be part of compliance, needs to be rolled out safely, and needs to be rolled back safely. It goes through a different process when it's about actually deploying your code to a target, right? Even phones, applications could also be a target, right? And so there are many different things that we can consider a target. Even deploying your code into a Hadoop cluster is a target, right? We have to think about how to do this. And so in the last 10 years, right, most people took a tool called Jenkins that was for CI, and they built their code and did linting, but they also used it to deploy. So they would deploy to EC2, and then they would deploy to S3, right? And then when new innovations came out, they would deploy to ECS, start a new Jenkins cluster. Oh yeah, we also still need to deploy to S3, and we still need to deploy to RDS or databases. So we'll have a database migration tool. And then when Kubernetes came out, it was the same thing. We'll deploy to EKS and S3. Now the problem with this is, of course, not only are you standing up multiple clusters to handle this multi-target, multi-cloud world, but also what was happening is that developers were taking scripts inside of Jenkins, and you would lose the knowledge of what is best practices. So as you deal with edge cases of EC2, when you do a blue-green, as you deal with rollbacks in EC2, you lose that knowledge because people were throwing it into scripts, and it was very hard to reuse because you were at the whim of whatever the developer wanted to put into those scripts. And so Netflix was dealing with the same thing. They had thousands of microservices, as many of you are moving towards, and there increases the complexity. And not only does it increase the complexity, you also want to package up the best practices of deploying into these servers. And so in 2016, Netflix, Google, Microsoft, Pivotal, all decided to open source this software delivery tool called Spinnaker. So what is Spinnaker and how can it help? So Spinnaker is a CD tool that came from Netflix that helps codify our best practices. So instead of thinking about the targets, think about the best way of deploying, right? Think about best practices. So this is blue, green. This is canary. This is rollbacks. This is auditing. And we would have continuous integration, right? These are concepts. These aren't targets, right? And so what we are doing is we're separating out the logic of deployments from the actual targets. And what this allows us to use is reuse these great best practices and concepts. So then what would happen is we could, do one for Azure VMs, right? Blue-green for Azure VMs. You can do blue-green for GCP VMs. We can do blue-green for Kubernetes. We can do canary for VMs. We can do canary for Kubernetes, right? And by abstracting this out, it saves us a lot of time from having to rewrite a lot of the logic that we had to do in the Jenkins world when we heard that there was a new service coming out from AWS or Google, which is every year we get hundreds of new services. We can now take the concepts, abstract them out from the destination. So how would this look like in practice? Most pipelines look something like this. You build, you test, you get some sort of approval, maybe you deploy to stage. So I'm going to put the deploy in blue, and we'll do EC2. Then we'll go, maybe you get the QA team involved. And then maybe you get the security team to make sure they do penetration testing. And this goes on and on till you get to, maybe another approval. And then maybe at that point you deploy to prod. Now the way that Spinnaker will help you in this multi-target world is, if you notice, we only have 2 deploy stages, right? What we have been doing with Jenkins is rewriting all of this, all of this, all of this, every time we had a new piece of infrastructure. So if you want to save yourself time using Spinnaker, you can still call out into Jenkins. We can still keep these the same, because Jenkins is an incredibly powerful and wonderful tool, right? Because Spinnaker has first-class support for Jenkins. And when you need to swap these out, Spinnaker also has first-class support for these targets. So changing this and swapping EC2 out for EKS becomes trivial, and you get it out of the box declaratively. And so when you think about Spinnaker, it's not about, in fact, the deployment targets. It's about codifying the best practices that are out there in the world for software delivery. Software delivery is a lot more than just deploying code. It's about shipping ideas and getting them into production. It's about all of the hard work that all of us do together and combine a work and effort from a lot of different teams. It's an endeavor in human collaboration. It's how we work together. It's how security, QA, operations, developers all work together. Because delivery isn't ever done. We may never be perfect, but we're always trying to iterate towards that perfection. And when we focus on best practices and we focus on our practice, we can eventually get there collaboratively. Thank you.